Okie dokie. So here we are talking about arithmetic sequences, and a sequence is arithmetic if something is added or subtracted every term. So we've been practicing with recognizing patterns. Here's an example: 11, 13, 15, 17. So you'll see that this increases by 2 every time. So what we say is that the common difference is a positive 2. That's the, see, it's the difference, and it's a difference, and it's a difference, and it's common to each successive term. We have another example over here: 8, negative 2, negative 12, negative 10. So you see that we subtract 10 every time. So we'd say that the common difference is negative 10. Okay, so basically we're learning some patterns for finding formulas. First we have recursive. And so what a recursive term says is that any term is equal to the term before it plus the common difference. So let's write that in words. It's very easy to get confused with the notation. So this is any term, and a sub n minus 1 is what we call it, is the previous term. For example, the 10th, no, I'll do this, the 11th, that's a sub 11, and so this would be a sub 10 over here plus d. So we could say that the 11th term is equal to the 10th term plus our common difference. And then again, d is common difference. Okay, so let's look at this example. We have, hey, go back. We have, alright, 9, 4, negative 1, negative 6, negative 11. So hopefully you're recognizing that we subtract 5 every time. So here's what we would say. We would say that d, the common difference, is negative 5. So a recursive formula for the sequence would be a sub n, any term, equals a sub n minus 1, the previous term, minus 5. So again, this is a recursive formula for this sequence. Let's say we wanted to know this, and we were getting to this. You'd have to know that this is the 4th term, alright, and this is the 5th term. So you could just plug in, and you could say that the 5th term, a sub n, equals the 4th term minus 5, and you'd get negative 11, which is this. Okay, another example. 11, 13, 15, 17. So it looks like the common difference between these terms is 2. So we could write in a recursive formula that says a sub n equals a sub n minus 1 plus 2. Like so. Alright. Now let's talk about explicit formulas. So again, recursive, one term is defined as a function of the previous term and then the difference between them. But for an explicit formula, all you need to know is the term number, so n, and you can find the value of any term. So these formulas would be good things to have in your notes. Oh, hey, here they are in your notes. But anyway, this we'll be using for this, and this we will be using to find explicit formulas. For arithmetic notes, next time will be on geometric. So here we go. 2 examples. Same examples, only this time we're writing explicit formulas. So we have to say a couple things. First of all, a sub 1, which means the first term. So a sub 1 in this case is 9. Sorry that the a's and 9's look kind of similar. The common difference is 5, negative 5, excuse me. So what we can say is that a sub n, so the value of any term, is equal to the first term plus, so we're looking at this, first term plus n minus 1 times the common difference. So n minus 1 times the common difference, which is -5. So this formula has a specific form, but you may distribute. So you'd get 9 and then minus 5n and then plus 5. So we'd end up with, wait, n minus 1. Alright. So we would end up with 14 minus 5n. So this is the same formula, just distributed, alright? So this is what we would get at first. In all the practice that we've done previously where you were recognizing patterns, you may have come up with something like this. But notice that these two are the same. Both would be acceptable. Okay, next example. Let's see. We have this, 11, 13, 15, 17. So we have already established that the common difference between them is 2. Our first term, so a sub 1, is 11. And so again, using this formula, we can say that the value of any term is equal to the first term plus, and we have n minus 1 times the common difference, which is 2. So this is just fine. If we were to distribute, we'd get 11 plus 2n minus 2, which is, so a sub n equals not 13, that would be 9 minus 2n. Whoops, little pause there. I mean plus 2n. Okay, moving on. Alright, here, finding the nth partial sum. So, what this means is we're finding, we're adding them all up to some value. So, for example, what we're going to be doing here is finding the sum of the first 100 terms. So you can sit there all day on your calculator, or you can use a shortcut, which is what we'll be learning. Okay, so two ways to think about this. And normally I will just teach this. So here S sub n is equal to, so the sum of the first n terms is equal to whatever n is times the average of the first and the last. But there's another form of this equation, and that is this over here, where instead of actually finding the last term, we're using the explicit formula for that last term. And so it looks different, but these are basically the same thing. But anyway, here they are, and so we'll use both. So you have those formulas written down, and let's just make sure we know what they are. So a sub 1, that's defined as the first term. N is the number of terms. A sub n is the last term. And is there something else? Yeah, D is the common difference. Alright, and so again, these all apply to arithmetic. And I know it says it on the first page, but maybe just write this up here so you don't get confused later. Soon we're going to talk about geometric, but not today. Okay, so for these examples, here's what I'd like you to do. For each question, find the pattern, write a recursive and explicit formula, and find the sum of the first 100 terms. Thanks. So before I show you the answers, here are our patterns, our numbers. Excuse me. So what you might want to do is write these down, 1, 3, 5, 7. And then, for example, 2, we have 5, 1, -3, -7. And then, for example, 3, -50, -40, -30. Maybe try to actually use what you just learned. So this, or this, for finding the sum. And then on the previous page, finding a recursive and explicit formula. So you could put this on pause. There's your pause button, and do that. Or you can just watch and I'll show you the answers. Okay, welcome back. All right, so what do we have? Bunch of stuff. So first, when you recognize a pattern, okay, we add 2 every time. So we say that the first term, a sub 1 is a 1, and we say the common difference is plus 2. So using the formula as our recursive formula, we can say any term is equal to the previous term plus 2. Boom, there it is, recursive formula. Explicit formula, we say a sub n is equal to first term, and then n minus 1 times 2. Boom, there it is, explicit formula. So again, this will give you the value of any term just in terms of the term number. And then recursive, you have to know the previous term in order to find the next term. The sum of the first 100 terms, maybe you sat there with your calculator and typed away and got 10,000, good work. Or we can substitute in. So here we have n. Let's see that formula. Where'd that go? Alright, so we are substituting in n is 100. Value of our first term is 1. N is 100, and the common difference is positive 2. So that's how we got this. I calculated, got 10,000, and then I did the same thing where using the explicit formula, so this is the top right formula for the sum of the first n terms. We have the first term and we have the last term, and I figured out the last term using the explicit formula. If you plug in 100 right here, you're going to get 1 plus 99 times 2, 199. So this is the average of the first and last terms, and we multiply that by 100 and we get 10,000 as well. So both of these work. It just depends on what information you have. Goal number two. So we have this. First term is 5. A sub 1 is 5, first term. Common difference between them is negative 4, so we're adding negative 4, subtracting 4 every time. Recursive formula, a sub n equals a sub n minus 1 minus 4, meaning any term is the previous term minus 4. Explicit formula, a sub n equals first term 5 plus n minus 1 times negative 4. We can leave it in this form if we want. We could also distribute as well, and it, in my opinion, looks a little neater. Substituting in to find the first 100 terms. So if we add them all up, what would we get? So we can use the formula in the top left of the page, and we end up with negative 19,300. Or we can use the explicit formula to calculate the 100th term. So this is the first term, and this is the 100th term. And we take the average of them, and we multiply by the number of terms, which is 100, and we would get the same thing. Alright, so again, either way is correct. I'm just showing you that both work here. And lastly, maybe you got this already. First term, negative 50, so a sub 1 is negative 50. Common difference between them is plus 10. So we can say the recursive formula, any term is equal to the previous term plus 10. Explicit formula, any term is equal to the first term plus n minus 1 times 10. And you could again distribute as well. Okay, finding the sum, aha! I didn't show work for you, so you get to show work here. And I think that I solved it both ways and ended up with this, so go for it. You got a little space there, and I'll see you next time. Thanks for listening.